Yeah, this is a line through which there is a point through which line is passing. And then what else you need?
And the DRs of the line.
Yes, DRs of the line. Good. DRs. DRs of line. So let's say DRs of the line. If you don't know DRs of the line, generally you take as ABC or DR.
ABC.
Okay, if you don't know anything, so ABC. ABC are DRs of the line. Yes. Okay, if you have these two, so equation of line, true, A whose position vector is A bar, and generally we say generally parallel to B bar. That means what? So B bar is a vector. So B bar is parallel to B bar. Okay, if it's parallel to B bar. So what is B bar? So here, this is with position vector we write. So A, B, C. DRs are A, B, C like this. So, yeah. DRs are A, B, C. Okay, right. So then what is the equation of line then? Vector form?
So vector equation is R bar is equal to A bar plus alpha B bar.
Okay, T B bar or lambda B bar, whatever.
Sorry, lambda. Yeah.
Okay, whatever. A bar plus T B bar. Okay.
Yes, sir.
And then next. So this is vector equation of a line passing through A bar whose position vector is B bar. Okay. All right. So
yes, sir.
Yes. Do you know why is this? How do you get this one? You take any, if you take any point, you can take any point on the line whose position vector is, let's say P, whose position vector is R bar. Let's say any point on the line. Then, AP is always parallel to AP is always parallel to B bar. Okay, sir, no? AP is parallel to B. Then AP equal to what? TB bar. Yes, sir, no? If there are two vectors are parallel.
Yes, sir.
They differ only in const. So AP is what? OP minus OA. OA is A bar equal to TB bar. This is how we get. R bar equal to what? A bar plus TB bar. This is how we get. Okay.
Yes, sir.
This is what is the equation of, yeah. So if you write this one, no, R bar is what? If you don't know, general point is Xi, no? XI. So Xi plus. So if you don't know, this is general point, no? General point Xi plus Yj plus Zk. Okay, this is R bar. Equal to A bar means what?
Yes, sir.
X1i plus Y1j plus Z1k.
Yes, sir.
Plus T into B bar. If you don't know, then we write AI plus BJ plus. We write like this. So then what you get is, so this one you get as, so if you write parametric equations, parametric. So parametric equations, if you write, so if you compare I coefficient is X, here I coefficient is X1 plus TA. So X equal to X1 plus AT. Okay. Y equal to Y1 plus VT. Z equal to Z1 plus CT. This is very, very important. Very, very important because point, if you don't know general point, you take this as general point. Let's say you want any point on the line is R bar, right? P R bar is any point. That is this one. X1 plus AT, Y1 plus BT, Z1 plus CT is, you can take, if you have to find out foot of perpendicular or any point with a distance, you have to take this like this. Okay. So then from you get a symmetric equation or you get a Cartesian form. Cartesian form is what? X minus x1 by a. X minus x1 by a equal to y
minus
equal to z minus z1 by c. You understand? Equal to some t or lambda, whatever. This is what is the equation of line passing through a point and parallel to another vector having. So our another way you can say is, let's say this line we have, Okay, this is passing through a point x1, y1, z1. So I am not taking now vector form. I am just writing its parameter, its Cartesian form only, and having drs. So drs of this line. So drs of this line is ABC are the drs of the line. So what is the equation of line? Now equation of line. See, now equation of line is what? Now here you take any point here also p x1 y1 z p x comma y comma z is any point. Okay, then what are the drs? Drs of AP. Okay, drs of this line AP is what? What are the drs now? You see x minus x1 comma y minus y1 comma z minus z1. Yes or no? Drs you can find out. No, drs of the line you can find out because you have 2 points A and P, right?
Yes, sir.
These are also this also dr. These are also dr. These two are proportionate. That means what? X minus x1 by proportionate. Na? All the two drs are same. So that means what? Always drs are always proportionate. That means x minus x1 by a equal to y minus y1 by b equal to z minus z1. See, they are proportionate, equal to some lambda, t, or whatever. If you don't write also, this much is equation of line.
Yes, sir.
So from this, you can clearly understand that if it is passing through a bar, and b bar, if it is passing through 2 points, then you have this is a vector. A b bar is your vector. You understand? Previously, it was b bar. B bar was a vector. Now a b bar is a vector. Now p any point you take. So now AP is what? Now AP is parallel to AB bar. Previously it was B bar. Now AB is a vector you got. Now AP equal to what? T into AB bar. So like this you have to understand. AP is what? OP minus OA equal to T times B bar minus A bar. So which is nothing but R bar equal to A bar plus T B bar. Instead of B bar, it is B times you understand instead of B bar it is AB bar, which is B bar minus A bar. Yes or no? If you want, you can write this. You can write like this. So, so here, if you take now
Yes.
minus t, 1 minus ta bar plus tb bar also you can write. But anyway, you understand it's passing through 2 points. If it is passing through 2 points, instead of ABC, you will have x minus x1. You understand? So here, x1, y1, z1. So this is x2, y2, z2, right?
Yes, sir.
Here instead of this, what you get is if you at all you want, it's a Cartesian form, then x minus x1 by x2 minus x1. Yes or no? ABC are x2 minus x1, y2 minus y1, z2 minus z1. These are points, right?
Yes, sir.
So do you know how to find out its do you know how to find out foot of perpendicular? Did you learn that? Foot of perpendicular point on the line.
We did a question on that only from the exemplar. I think I forgot the formula. 1 second. I don't remember. I was.
No, equation. This is very important actually.
Yes, sir. I'll learn it.
Okay, so what shall we do is now we'll have a revision. We'll have a revision. So in this application of derivatives, first rate of change of quantities. So with respect to variable x, so y there is a change in y. So as x changes, y also changes. That rate of change we call that is dy by dx. So if it is with respect to t, dx by dt. So that's what he said. No, first rate of change of y with respect to x is dy by dx. Thus, s represents the distance and t distance. So then ds by dt is what? Rate of change of displacement with respect to time. Okay, that is ds by dt. So that is very simple, right? First exercise, rate of change of quantity is very easy. So tangents are approximations you don't have. So increase and decreasing. So you remember increasing and decreasing as x increase, here.
Sir, yes, I remember it.
F of x1 also increases, then it's called increasing. As x is increasing, f of x is decreasing, you see. F of x1 is less, greater than f. That means what? Decreasing, right?
Yes, sir.
So then what do we say? It is decreasing function, right? As x increasing, see, x1 is less than, x2 means what? x1 less than x2, less than x3, x4. Then f of x also increasing, like this now we say. So like this, as x is increasing, f of x is increasing like this, then it's increasing function. As x is Increasing, f of x is decreasing, then it's called decreasing function. Yes or no? So, but increasing function means what rate? Slope of the tangent is what? Tan theta is greater than 0, dy by dx is greater than 0, f dash of x is greater than 0. So this is what? Slope of the tangent is what? F dash of x less than 0. So, but where?
Yes, sir.
Important, where? That's important, where? So from, so sometimes, so this function is what, right? This function is from here to here, it is decreasing and then it is increasing. So that means what? From here to here, it is decreasing, right? So where it is, yeah, it is decreasing. From here to here, it is decreasing, and from here to here, it is increasing. That means what? From A to B, if you consider, then it is, you can't say it is increasing or you can't say it is decreasing. So what we say, neither increasing nor decreasing, but from A to C, it is decreasing. C to B, it is increasing. Sir, no? Remember?
Yes, sir.
That's what. So if at all no, he says increasing f dash of x greater than 0, you should take. Decreasing f dash of x less than 0, you should take. Okay.
Yes, sir.
So of course, function has to be continuous, then only continuous. F has to be continuous in closed interval AB and differentiable in open interval AB. Then only we say f is increasing in closed interval AB if at all f dash of x greater than 0 for all values of x in this interval, right? Increasing, decreasing f dash of x. So the function is constant, f dash of x is 0. Yes or no?
Yes, sir.
If dash of x is not changing, right? Like this only it's going. That means what? Neither increase. So now you can't say here neither increasing nor decreasing. This one you should say constant. Understand? This one you should say constant.
Yes, sir.
So this is neither increasing nor decreasing is different. It's actually if it is decreasing and then increasing, or first decreased or first increased and then decreased, then it's called neither increasing nor decreasing. That's it. Maximum and minimum. So here we have local maximum, local minimum. Okay.
Yes, sir.
What is the definition? Local maximum definition what? So if you consider in the interval of C, so now in the neighborhood of C, this is C minus H and then C, this is C plus H. Okay. So now it is like this, let's say. So here we have local maximum. So that means what? F of C.
Yes, sir. It's going from from
X,
lesser value to more.
yeah, X1, X you are taking in this interval, right? C minus H2,
Yes, sir.
C minus H2, C plus H you are considering. So f of C is the greatest. F of C is greater than f of x when x belongs to C minus H2, C plus H. Okay, that's what is now local maximum. Local actually. Local means what? In the neighborhood of C. Neighborhood. Okay, in the neighborhood of C. Only this much only you consider. So this is what is maximum. So it's what is local maximum. So similarly, local minimum. Okay. For local maximum and local minimum, first derivative, right? First derivative will be 0, right? F dash of C is 0, right? F double dash of C will be less than 0. Local maximum. Yes, sir?
Sir, I didn't understand.
Local maximum, for local maximum, local minimum or local maximum, F dash of C is 0, right? First derivative,
Yes, sir.
but second derivative will be less than 0. For maximum, it is less than 0, for F double dash of X is, if double dash of X is less than 0, then F will have maximum.
Yes, sir. Yes, sir.
We did know so many questions on that.
Yes, sir. Yes, sir. Now.
So we say now, yeah, we'll see now. Critical point. What is critical point? You remember? Two things. Either
So,
means what? Critical point means what? Try like this. See, so now we'll draw a line like this. And then it is like this. And suddenly graph became like this. And then we have like this, let's say. Like this we have. See now what are the critical points? So a point C in the domain of the function, okay, at which either f dash of x is f dash of C is 0, f dash of. So here f dash is 0, yes or no? Slope of the tangent is 0, yes or no?
yes, sir.
So here also 0, here also 0. Here you see, this is what is also critical point, right? But this is vertex. Here you can't say. Here f dash of x is not defined. Understand here. Understand here, f dash of x is not defined.
Not defined.
Not defined. So what is that very important thing? F of x equal to a mod x. You remember mod x, right? So then f dash of x, this is critical point, but here f dash of x is not defined. F dash of x is not defined. Okay?
Yes, sir.
Critical
Yes, sir.
point only. So this is also critical point, but f dash of x is not defined. Here also critical point. If the f dash of x is not defined, like this. No, now let's say this is x-axis.
As if it's a vertex, it's never defined.
Yes, and endpoint also. Endpoint also not defined.
Yes, sir.
But still it is a critical point. These are all critical points. So therefore, what is critical point? Either f dash of x is 0 or f is not differentiable is called critical point. That means what? Why is this critical point? Critical point means what? Where you will have either maximum or minimum. Okay.
Yes, sir.
So now what is first derivative test? First derivative test is what? So now if you f dash of x, see, this is f dash of x changes its sign from, okay, you see here, from positive to negative. Okay. This f dash of x is positive, yes, sir. But here f dash of x is negative. You understand?
Yes, sir.
Why? Because theta is tan theta. So theta, no, here, theta is what?
Yes, sir.
Now,
Tan theta is negative in the second quadrant.
tan theta here, this is f dash of x, which is greater than 0. Here, acute angle, na? This is obtuse, so it is negative. So that means what? If at all, if
Yes, sir.
changes its sign from positive to negative, it will have maximum. If it changes its sign from negative to positive, then it will
Positive. It'll have
have
minimum.
minimum. Okay. Understand? That's next point. That's what is first derivative test. Okay. So if dash of x
Yes, sir.
from negative to positive, then it is C. So that means what? Increasing to decreasing. That means what? C will have local minimum. Okay. Okay. If it doesn't change its sign, if it doesn't change its sign, okay, it's not changing its sign. That means what? C is neither a point of local maximum or local minimum. Sometimes what happens, f of x equal to x cube. This example is given generally. So what happens is here, like this. Instead of it goes this side, same it goes this side. Understand? So f dash of x is
Yes, sir.
3x square. If you equal to 0, x equal to 0, that x equal to 0 is here. Yes or no? X equal to 0, y equal to 0 is origin. Yes or no?
Yes, sir.
See here, f dash of x is 0. That means what? F dash of x is 0 at 0. F dash of x is 0. That means what? Here, this point, this is what f double dash you do. F double dash, if you do what you get, f double dash of x is what? 6x. So f double dash
6x.
0 is 0 only. That means what it is? Minimum, maximum, we are not getting. You understand? You have to go to first derivative. First derivative also, it's not changing its sign. Okay, if you draw a tangent here, it is only positive. It's not changing its sign. That means what? This is not the point of local maximum or local minimum. This is called what? Point of inflection. Okay, sometimes
Yes, sir.
change. If it doesn't change, then we have to say it's point of inflection. What is second derivative test? Now, just now I told f dash of c is 0 and f double dash of c is less than 0. Local maximum. F dash of c is 0.
Yes, sir.
Dash of c is greater than 0. Local minimum. F dash of c is 0. F double dash of c is also 0. Then what we should do? Go back to first
If
derivative
the
test.
test fails, then we have to go back to the first
Very
test.
good. Good. So these are the concepts, right? Right.
Yes, sir.
Do you remember absolute maximum, absolute minimum? So all
Uh,
take. So from A to B, you have to take all the points. From A to B, you should take all the points, right?
yes, sir. Including A and B.
Including A and B. And you have to substitute and check. Second derivative test is not required, like this. Let's say you have like this, you have. So now here what? This is maximum and this is also maximum, right?
Yes, sir.
Yeah, so you have to substitute these 3 points, right? Then points per minimum. Okay, then all actually you will get all points. This is no, these are the critical points you get. And here this is A and this is B. You have to substitute all these points. Let's say you have x1, this is x1, this is x2, and this is x3. So you have to substitute A, B, C, x1, x2, x3, and whichever gives you maximum, that's That's what is absolute maximum, whichever gives you minimum, that's what is absolute minimum. Very simple, right?
Yes, sir.
All right, so these are very simple questions because here this is rate of change. For the curve, if x increases at the rate of 2 units per second, then how fast is the slope of the curve changing? Slope of the curve is what dy by dx, that's all. Okay,
Yes, sir.
so how fast to see is here. So here, example questions will, somewhat twist it will have. So you should understand very quickly, very deeply you should understand. Of course, quickly also deep. So what is saying, if x increase at the rate of 2 units per second, x increases at 2 units per second, right? That means what dx by dt is what is given. You should write whatever information is given. First, you should write. So the curve f of x or y is this. And then x increase at the rate of 2 units per second. This is what dx by dt is given. That is 2 units per second. 2 units per second. Okay. Then how fast is the slope of the curve? Slope of the curve is dy by dx. Okay. How fast is the slope of the curve changing? So that means what? How this is how what is the change in this rate? That is d by this of dt is the question actually, Slope of the curve is dy by dx, na?
Yes, sir.
D by dt of this thing you should find.
Yes, sir.
Ah. So that's the reason see he wrote like this. Okay. So first of all, what you should find dy by dx. What is the dy by dx? Say pi o minus pi o minus 6
6
square. Okay. Then you have to differentiate now. Both sides differentiate now. We have to differentiate with respect to t because I want d by dt of this thing.
Yes, sir.
So this is a tricky. You see, this trick. If you don't do this one, then you will not understand it all. In exam, you will not understand this. Sir, no. Good.
Yes, sir.
Yeah. So now dy by dt. So now,
So we just do d by dt of dy by dx to get the
yes,
answer when they
exactly.
say how fast is the slope of the curve changing.
Correct. Very excellent.
Yes, sir.
So that means what, So now d by dt of dy by dx. That means so we got this one. So now
Minus 12x.
dy by dx equal to what? Minus
Hmm.
12x into dx by dt because it is respect to t. And that's all.
This is equal to 2.
X is 3. And dx by dt is this one.
Yes, sir. So we can find dx by dt. And that is the answer.
Dx by dt is what, right? This one only, no?
Okay, sorry. Yes, sir.
Dx by dt is that's all. This is what you need to find. So I told you what is it.
Yes, sir. D by dt of dy by dx is the answer.
How fast is the slope of the curve changing? This is what slope of the curve. Okay, Ray. So dy by dx is nothing but what, Ray? F dash of x, you can say Rm. Dm by dt is what is the question? R. Like that. Understand?
Yes, sir.
So anything like that is there something. Yeah, this is no general question only, but it's important. Water is dripping out from a conical funnel of semi-vertical angle pi by 4 at the uniform rate of 2 centimeters square per second in the surface area through a tiny pore at the vertex of the bottom. When the slant height of the cone is 4 centimeters, find the rate of increase of the slant height of water. You understand? First, whatever is given, you should write. Whatever is asked, you should understand. Okay? Shall let's do this. First,
Okay.
uh,
Nothing, sir. We'll do the question.
yeah, do it. So, what is
Sir,
dripping?
I understood the question, so I was about to say
Hmm.
because you explained it last time also.
Oh, this one I finished.
Yes, sir.
Then, okay, so then we'll go. So this is not there. Find angle of intersection. That's not there. Okay.
So this, I think I did all the questions till I finished. I think even long answer, there are only 3 or 4. I think I did all the examples, but not the exercise.
Oh, really? So then we'll go to exercise.
Yes, so because I think I now remember when I asked you questions, you were like, this is not there in the portion also. So I think I remember doing it.
So what you have to go?
So but
What?
I'll go through all of it again, sir. And if I have any doubt, I'll ask.
Yeah, this is very important. Just you can go through it. So this one also we did rectangle inspection.
Yes, sir. I don't know if yes, I'll go through all of it. So if I have any doubts again, I'll ask.
Right. I remember. This one we did. This one also we did. I explained this one.
Yes, I had doubts in these questions at the end.
So shall we do again?
Sir, I'll do it on my own first, and if I have any doubt, then I'll let you know. Because um, so will we have class tomorrow?
No. So if we have any doubts, then we'll have class. There's no problem.
Okay, sir. Sir, I just remembered I forgot to send you the question paper, sir. I'll do it right now as soon as the class ends. I totally skipped my mind, sir. I'm sorry. Very sorry.
What is this exercise, right?
Yes, sir.
Okay. All right, so we'll start exercise. So shall we do exercise quickly? If it is so easy, we'll leave it. If it is not easy, then we have to do it. Okay, chalo. So shall we do it or?
Sir, I don't think I'll be able to answer all the questions properly. Like I remember the concepts, but I'll have to. So now that you explained it once, it'll be a lot easier, but I'll have to go through it once. I don't know if I'll get all the questions
No, that's okay.
fast.
Understand the concept, no? I revise the concept.
Sir, but,
So
oh,
now we have to revise it. Okay, otherwise, so we take some time and revise the concept. There's no problem. But here, what is the dx
yes.
dy by dt? The same thing only, no? So a spherical
Yes,
ball.
a few of the questions I'll be able to answer easily, but I'm saying it might take me a little time to understand and do it. So I'll, okay, yes, sir.
All right, so okay, all right. So we shall start. Okay, so we'll do the first question. So shall we do first question?
Yes, sir.
A spherical wall of salt is dissolving in water in such a manner that the rate of decrease of the volume at any instant is proportionate to surface. Prove that the radius is decreasing at a constant rate. That's what we should do. Spherical wall of salt is dissolving in water.
In such a manner, the rate of
Yeah,
decrease of the volume.
rate of decrease.
Um,
Dissolving means what? Decreasing of the volume. Rate of decreasing of, right?
yes, sir. So dV by dt.
dV by dt is proportionate to
At any instant
proportionate to surface.
surface. Yes, sir. So ds by dt. No, surface.
Yes.
So I don't know.
Yeah, just surface means yes. That's it.
Okay. Yes, sir.
So this is spherical wall.
So when they say surface, they mean surface area only, no?
Yeah, exactly.
4 by 3 pi r cube.
Volume. And then surface area is
2 pi r. No. So I think it's 2 pi. Okay, yeah.
4 pi r square. I remember 4 pi r square.
Yes, sir. 4 pi r square.
So actually like this now. This is what let's say hemisphere. We take consider hemisphere. So if you
So
can,
this is I was telling it for a cylinder for some reason. Yes, sir. 4 pi r square only. Sorry.
yeah, actually, so surface area is always, what is surface area? Surface area is, yeah, perimeter of the base, 2 pi r into height, right? Perimeter of the pH, right? Perimeter of the base into height. Even for cylinder also, for the cylinder also, for the cylinder also, what is perimeter of the base is 2 pi r. 2 pi r into height, 2 pi r h. Sir, no?
Yes, sir.
Surface area is 2 pi r h, right? Here 2 pi r into r, 2 pi r square. But this is only hemisphere wala. Okay, this much only, hemisphere only. Then one more is there, na? Another another part is also 2 pi r square. So total 4 pi r square. So this is, so now dv by dt. Okay.
Yes, sir.
dv by dt. What is dv by dt? Is 4 by 3 pi into 3 r square dr by dt. Okay. Is proportionate to s is 4 pi r square.
4 pi r square. Yes, sir.
So 3 cut, 4 pi cut, r square cut. So what is there? dr by dt is simply proportionate to what? So what you should write, Proportionate means what, right? Constant, right?
Yes, sir. Is equal to k, huh?
Constant. So what is saying? Prove that the radius is decreasing at a constant rate. That's what is this. So, but the volume is, see, this volume also so decreasing, right? Decreasing is what?
Yes, sir.
Minus s. This is minus. Actually, you can write like this. Right? First only dv by dt is equal to minus ks. You can write. Understand?
Yes, sir.
You can write like this. dr by dt is minus k. You can write like this.
Yes, sir.
So this means radius is decreasing at a constant rate. Decreasing at a constant rate. Simple. This much only.
Yes, sir.
Okay, all right. The next area of the circle increasing at a uniform rate. Prove that the perimeter varies inversely as the radius. So this one is easy, direct. Okay.
So dA by dt is equal to is inversely proportional. Wait. Yes, sir. Got it.
Uniform rate. What do you mean by uniform rate? Area of the circle increases at a uniform rate. What do you mean? What does it mean? Then prove that perimeter varies inversely as the radius.
So dA by dt is going. So we just take dA by dt is equal to d by dt of pi r square. No, over here.
A by dt is what? Given the area of the rate increases at a uniform rate means what?
Is equal to k.
Okay, constant, yeah.
Yes, sir.
Okay, so that's okay.
And then k is going to be equal to d by dt of pi r square.
Correct.
Yes, I got it.
So 2 pi r into dr by dt.
dr by dt is equal to
Okay.
k.
So that's, see now, dr by dt, dr by dt equal to k by 2 pi r.
Yes, sir.
What is the, prove that perimeter varies inversely as the radius. This is perimeter, right?
Yes, sir.
Perimeter varies inversely as the radius.
Yes, sir.
Last time also we did, perimeter
Yes, sir. Yes, sir. Now I remember.
inversely has a radius. So last time also we got
Sir, so I think if I do them, I will get them,
correct.
the questions, because I also remember discussing them now. Oh, okay. Yes, sir.
Okay.
So short answers, so we definitely discussed all of them. Um,
Man walking this is also there. This is not there. Fifth, sixth, seventh is not there.
yes, so fifth, sixth, seventh is
Sixth,
not.
yeah, sixth, seven is not there. Man, this is there. Eighth is there. We did not do actually all this. We did not do, but nine, 10. This all we did not do. Only few problems we started and we did few problems. These all tangent normals actually. 20 is there.
So all of them between are not there. Lot of
Many are not. These are all not there. 15, 16, 17, 18, 19 not there.
yes, sir.
20 is there increasing. Yeah, you can very clearly